So this is the second lesson from Chapter 8 on arithmetic sequences. And actually what I have on the board here is actually an arithmetic series. So series is when you add together a sequence of numbers. Quite a simple sequence here. This is just our counting numbers. First term is 1, difference is 1. Now this is actually a problem that was solved in the 1780s by Carl Friedrich Gauss, who was only, like I said, he was only 8 years old at the time. And the way he solved this problem was not to do it like this. But what he noticed was if you wrote the sequence backwards and then added the two numbers together, then what happened is when you add this together you get 101. When you add this together you get 101. In fact, every term turns out to be 101. And because of the way we've set this problem out, there's 100 numbers here and they all add up to 101. And 101 times 100 is 10,100. Now the only problem with that is that's actually the sequence twice because we wrote it twice. So if we divide this answer by 2, then that will actually give us what the answer to that sequence is. So finding a sum of a series, a very clever way of doing this is writing it forwards, writing it backwards, and then adding it together, and we can see what the pattern is. Now this also comes back to something that we talked about before, which is actually what we have here is n plus 1 divided by 2. So we talked about that when we did triangular numbers in an earlier lesson. So that is a very useful formula for actually finding the sum to n terms. Now what we're going to do is, rather than just looking at 1 to 100, we're going to look at a generalized sequence. So if we're doing the sum to n terms, the first term is just a. And then to find our next term, all we do is we add on the difference. So this would be a plus d. And if we add on another difference to this term, we'd have a plus 2d. There we go. And all the way until we get right to the end. And as we saw last lesson, the form for the nth term of something is a plus n minus 1d. Now also notice that for my second term I have 1d, for my third term I have 2d. So always the number of d's is 1 less than the actual term. So another reason why this is a plus n minus 1d. Now if we do the same idea as we did in the previous example, is we want to write this sequence backwards. So the first term would be what the last term is up here. And then we're going to count backwards. So the term before n minus 1 would be n minus 2. And keep going to do this all the way until we get to the end. Now actually the end is the same as the start of this sequence, so this just would be a. Then what we did is we added these together. So we got like terms here, so a plus a is 2a plus n minus 1d. A plus a is 2a. Now we got n minus 2d plus 1d, which is also n minus 1d. So actually, when we add these together, and you might remember from the previous example, when we add them together by going forwards and backwards, we always end up with the same total anyway. So once you add these first two terms together, you know that all these are going to be the same. Now, as we have n terms for this, if we add all these together, this would just be n times this. Now notice by adding s of n and s of n, I got 2s of n as well. So I can say that 2s of n equals that expression there, n times each one of these terms, and then just to find s of n, all I need to do is divide by 2. And that's the formula that some of you will be familiar with from Algebra 1. Now there's another way we can rewrite this formula as well. The 2a plus n minus 1d, notice we got together by adding this term and this term together. So as this is the first term and this is the last term, we could also say s of n equals n over 2, first term plus last term as well. So you've got a choice of two formulas. If you know the last term, that's obviously a much simpler formula to use. If you don't, and perhaps you know what the difference, and perhaps you know something else, the number of terms, then that would be the one to go with. Now, there are different ways of tackling this problem, but if we're going to find the sum to the first n terms, then we know we're going to need that formula. And part of that formula says we need to know the first term, which we don't know right now, the number of terms, which we do know 10, and the difference. So what we're going to do is we're actually going to set up an equation to model these first two sentences that we're given. Very important that it says arithmetic sequence here. So we know the formula for an nth term of a sequence is a plus n minus 1d. So we can use that on our first expression. So n minus 1, so 4 minus 1 is 3, and we know that that term equals 21. We can do the same with this one, a plus n minus 1d, where n is 7, so 7 minus 1 is 6. A plus 6d equals 39. So we've set up a system of equations with a and d, and then we should be able to solve. If we subtract here to cancel out the a's, then we get negative 3d equals negative 18, and d equals 6. If we substitute back into one of the formulas, 3 times 6 is 18, a plus 18 is 21, that will tell us that a is 3. And then we should have all the information that we need now. We have a, we have d, and we have the number of terms that we want. So we should be able to find that sum to 10 terms. So there's a formula that we had before. As I don't have the last term, I'm going to go ahead and just use this formula and then substitute in the appropriate values. So n was 10, a was 3, and d was 6, and once again n was 10 there as well. And if we substitute in, we can get 300. So a little more complicated than the questions you would have done in Algebra 2.